Alright, I'm Chris.
I'm Parker.
I'm Maria. I'm Anna.
This is Rainbow Route. So, I'm a rock climber, and I thought it would be really cool if there was a way to autonomously change the routes on the wall. Because going to the wall a lot, you notice that there isn't a lot of time where they take down and put up new holds. So it would be nice if you can climb something different without having to wait for whoever works there, the staff, to change each of the routes out. So we came up with a way that you would be able to control each of those holds on the wall via app, Android app. And you would be able to save, load, and define your routes, and it's got a user-friendly interface. So each node on the route has two holds. So each Arduino has two holds, and the whole all the holds are controlled via RS-485 bus, which is controlled via the hub at the base and communicates Bluetooth with the Arduino app. You can create, delete, and update all of the memories of the nodes in the hub via Arduino and via Android, and the conditional page flow of the app depends strictly on the status of the wall. So this is just the basic overlay. We have the app, the hub, and the nodes. The splash setup, configuration, and climb, these are all the pages involved in the app, and the Bluetooth module, Bluetooth hardware that communicates with the Bluetooth module in the hub. And then you have the Arduino Mega, which is the hub with its own EEPROM, that communicates via RS-485 bus to each node, which has two holds again, and each Arduino node.
There's also an EEPROM in each of the nodes to store like what routes they belong to.
Which you'll see later.
Yeah. So when we first started out the application writing for this project, we didn't really have a specific structure as to how we were going to factor our code. So later on we decided to divide it into the application layer, the data, the Bluetooth, and the hardware. So the application layer basically consists of just the interface, pages, the buttons, so all of that stuff that the user can see. The data layer contains all the node information, the wall name, route names, addresses, stuff that is in the background. And the Bluetooth is basically the classes that handle the Bluetooth communication between the app and the hub. And then there's the hardware. So to go more into the specific of the Android app, so this is our class organization when it comes to the wall structure. So the bigger square, the white one, the wall, is a static class. There's just one wall, you can only create one wall. This wall class has a name, it contains nodes, and it contains routes that also must contain nodes. So each of these fields are a separate class by themselves. So wall contains routes, and routes contains nodes.
So our application workflow, these are kind of the main pages that we had going on in the app. These would start off with the splash screen. And that's where all the initial communication happens between the application and the hub. So it's kind of this conversation where the application goes to the hub and is like, is the wall configured? So if the hub replies back with yes, the wall is configured, it has been set up before, the application will then start asking about, well, all right, give me the nodes, give me their addresses, their XY locations, ask if there are any routes that have been saved to the memory of the hub, retrieves all of that information and sets it up for the user, and then it just redirects them to the climb page where everything will be set up and they can just start up using the wall. If the wall has not been previously set up or configured, so that would be a one-time thing. That's in the case that it's the very first time you're using the application or the wall, or the very first time that you're setting up the wall. It will redirect the user to set up the wall. And then the user will be prompted to kind of look at the wall and implement the layout of the wall where the holds are onto the application screen. After they have set up where the holds are, it's kind of eyeballing it, I guess, they will go onto the configuration page, and this is where we match up the application the different holds on the app with the actual holds of the wall. So the hub will light up a hold on the wall, and the user will just basically match it on their screen like this is what the hold is. And then that will associate an XY location with the address of that hold, and it will save it to the hub memory. So then the hub can basically relay all that information back in this splash screen when the user starts up the application again. And then afterwards it redirects them to the climb page where they can start climbing.
Yeah, so the advantage of this setup is that you can bring any tablet and link it to the wall, and it would just have the configuration on the wall. So instead of, we were thinking of storing the data on the tablet, but then we thought that there'd be an advantage to like having it stored on the hub.
So you can use the one application for multiple walls, and all the wall information is saved to the hub itself. So you would just retrieve it from the hub and use your one application for as many walls that support our product.
So in our climb page, which is the main page where the user can light up the nodes and set up routes, we have the following features. We can save routes. Within that save route feature, you are asked to name the route and then proceed to save it. There's also the load route feature, which pops up a list of the previously saved routes on the page, and each specific route has the option of either loading it or deleting it. And if you happen to press the delete button on accident, there's also that confirmation page. Make sure that you want to delete it. Otherwise, there's also a color select where you can choose what color you want your node to be or your hold to be. Currently, we only have about 7 colors because those are the ones that are most noticeable on the wall. And the reset feature basically just turns off all the holds on the app and on the hub.
All right, so moving on to the hub design. So the app communicates with its built-in Bluetooth hardware to a Bluetooth module, the third one that we've actually purchased for this project, using a string-based communication protocol that we came up with ourselves. It works with a basic handshake sort of algorithm, and it's pretty simple to monitor to make sure there's no bugs going on. The Bluetooth converts the signal coming in into one interpretable by the UART hardware on the Arduino Mega, which then relays the information to the main code where it's read, processed, and responded to. For this project, I wrote a bunch of libraries to keep everything modularized and layered so that it was testable and easy to organize. There's one for the memory stored on the hub, which basically just manages the EEPROM. It stores the XY locations of the nodes, their addresses, the wall name, whether or not the wall is configured, all the routes, their IDs, and relays all that reliably and hopefully as quickly as possible back to the app when it's asked for it. The hub bus library controls the data going out to the nodes. It encapsulates all of the serial communication with the RS-485 driver, which is emulated by the software serial library. Then moving on to the nodes, the communication protocol into the nodes is a much simpler one than the one between the app and the hub. It's byte-based instead of string-based. It's a little harder to manage, but it was pretty easily testable because it didn't have to be quite as scalable. The RS-485 driver takes the input from the RS-485 bus, relates it to the software serial library again, which interprets it as UART, the basic UART structure built into the Arduino. The main code processes it and everything. It has its own hold memory library, which I wrote and tested and everything, which holds all of the route memberships and whether or not the address has been set up for the node inside the EEPROM. A basic RGB LED library controls the 2 sets of RGB LEDs for the 2 holds that each node controls, which have varying levels of brightness using the pulse width modulation hardware.
So we had a couple issues. Android side, or the application side, a lot of them had to do with Bluetooth. So Bluetooth is a fairly well documented process. However, the documentation kind of assumes that the developer will be using it for app-to-app development rather than application to microcontrollers. We were doing it, and for one, so applications, they have human interaction. They're a lot slower to kind of respond than a microcontroller, which is basically instantaneous. So that kind of got us a couple issues. our page flow, so kind of the like Bluetooth nature and our application flow nature, they kind of conflicted in that we wanted to terminate all of our processes once completed. So if a user moves from setup page to configuration page, or from configuration page to client page, we don't want them to go back and change anything. So we had to terminate each process once completed. But the way Bluetooth works is that it assumes you're not terminating the process. So by terminating the process, you terminate the connection. So we had a lot of issues in there as well, kind of trying to figure out how to go around that.
And overall, our application works really well, but there are some times that it just doesn't connect to the Bluetooth module for some reason, and we never found out why. We're thinking that it might be more of a software issue than a hardware issue. And otherwise, the biggest challenge of it all was just getting used to the Android framework, because neither of us had worked with Android programming before.
So a big challenge we faced was Bluetooth documentation as far as the hardware goes. For the hardware and firmware, we did not find anything really substantially helpful. We went through 3 modules, the Bluetooth, Adafruit, EasyLink, which literally the only information on it we could find was communicating from app to an Arduino for reprogrammability, not necessarily control. And the second device we ordered never came. That was great. And the third one was the Mate Silver from Smartphone, which ended up working after a little bit of debugging.
We got it 3 weeks before the end of the project, so.
Limited time to use it.
The next biggest challenge we faced was the RS-45 driver chips we used were a lot more delicate than we thought they were. And we started with 25, and I'm pretty sure we have 8 now. Because every time we put them onto a breadboard or connected them to our own power supply circuit, they would fry and never work ever again. Next, the nature of the project demanded a highly scalable power system, just because rock walls are enormous and LEDs take a lot of power, especially that many LEDs. So without the tools to reduce the amount of power each node uses, we were looking at having to demand hundreds of watts of power easily, just for lighting up all the LEDs and nodes. The next biggest thing we faced was that when we ordered our parts, especially because we were ordering parts right in the middle of a really cold winter, everything kept getting delayed shipping-wise because there were storms everywhere and parts needed to ship from all parts of the States and one of them from China. It just got kind of really messy. And lastly, we, again, lacked all experience with a lot of the technology we were using across the board for the entire project.
Yes.
This was a very, very self-taught experience.
The learning process is fun.
Yeah. But otherwise, that's our project.
Let's go around.